Thank you everyone for joining. Let's just wait another 1 or 2 minutes for people to settle in. But just wait another 1 minute and then we will start the webinar. Okay, I think let's start. So once again, my name is Violet Sia from APJ Marketing of EDB. Good morning, good afternoon, everyone. Welcome to this webinar on EDB Failover Manager. We call this series of webinars Office Hour, and this is really directed at our customers to help you better understand and use the tools offered by EDB. The Office Hour webinar series is a joint effort by EDB Customer Success Team and Marketing. So before we start, I just want to go through some housekeeping items. Please note that all your lines are muted, but if you have a question, please write it in the Q&A box below. You can see the Q&A box icon at the bottom of your screen. Also, this recording and slide will be shared with you after the session. And to help us run future webinars for our customers on topics of interest to you, we ask for your help to share the topics you would like us to look at also in the Q&A box. So without further ado, let me pass the mic to our speaker, Amandeep Singh, Technical Success Specialist with EDB's Customer Success Team. Over to you, Amandeep.
Hello everyone, my name is Amandeep Singh. I am working as a part of customer success team at EDB. Today we will discuss about EDB Failover Manager. We'll also demonstrate its benefits. I hope today's webinar will help to kickstart the deployment of EFM in your production environment and to take the advantage of the features it offers. The agenda of this webinar includes EFM overview, installation configuration demo, and finally queries from your side. Let's start with EFM overview. Why EFM? Enterprise DB Failover Manager is an offering from Enterprise DB for managing high availability for community Postgres and EDB Postgres advanced servers using streaming replication on Linux. It enables a Postgres primary node to automatically fail over to a standby in the event of a software or hardware failure on the primary. Also, it helps you in ensuring business continuity by monitoring the health of your databases and identifying the failures quickly. It will also help you in maintaining high availability to meet your SLA by switching over to the most recent standby. Also, you can upgrade with minimum downtime. It supports on-demand switchover to move the primary node to standby for maintenance. Now let's discuss EFM prerequisites. Before using Failover Manager, you must first install Java version 1.8 or later. SMTP configuration is required to be in place so that in case of any event of failover and switchover occurs, EFM can send email alerts to concerned teams. Streaming replication. Failover manager requires that the Postgres streaming replication be configured between primary node and the standby node or nodes. Failover manager does not support any other type of replication. Modify the pg underscore hba.conf file. You must modify the pg underscore hba.conf file on the primary and standby nodes, adding entries that allow communication between all the nodes in the cluster. Ensure that the database user has sufficient privileges. The database user used for EFM should have sufficient privileges to invoke monitoring and management functions on behalf of failover manager. However, if you are using super user, you are not required to be concerned about this. Ensure communication through firewall. If a Linux firewall is enabled on the host of a failover manager node, you may need to add rules to the firewall configuration that allow TCP communication between the failover manager processes in the cluster. Supported platforms. EFM is supported on RHEL 8 and 7, CentOS 8 and 7, OL 8 and 7, SLES 12, Ubuntu 20.04, 18.04, Debian 9, RHEL on IBM Power Server 8 or 9. Now let's discuss EFM architecture. Basically, we need minimum of 3 nodes to set up EFM cluster. The first will be primary node. This will serve the read-write connection. Second will be standby node. This will be in a recovery mode with read-only connections. Third node will be either witness or second standby node. The witness node confirms assertion of either the primary node or a standby node in a failover scenario. A cluster does not need a dedicated witness node if the cluster contains 3 or more nodes. To start with, first we need to install EPAS or community version of Postgres on primary node and standby node. Database installation is not required on witness node. After the installation of database server, initialize the database only on primary node. Set up streaming replication between primary node and standby node. Installation of EFM is required on all the nodes, and EFM agent will use JGroup to communicate with other EFM agents. Once we are done with the installation and configuration of EFM, EFM will automatically assign VIP to primary node, only if VIP configuration is specified. Let us now discuss switchover scenario. Once we perform the on-demand switchover, our standby will become primary and old primary will become standby and VIP will be assigned to new primary node. The direction of the replication will be automatically reversed. All the read-write load will come to new primary node. Also, based on your mail configuration, the alert will be sent to specified user emails. Now let's discuss failover scenario. In the event of hardware or software failure on primary node, automatic failover will happen and most recent standby will become primary. As in case of primary failover, the replication will not automatically establish. However, if you have multiple standbys, those standby will automatically reconfigure and start pointing to new primary. Also, based on your email configuration, the alert will be sent to specified mails. For this demo, I am using one primary node, one standby node, one witness node, and virtual IP. CentOS 7.7 is used as a OS platform, EPAS 13 as a database server, and EDB Failover Manager 4.2. Now let's begin with the live demo of installation and configuration of EPAS, streaming replication, and EFM. So now we are on Enterprise GB website. To start the download process, click on sign in button on the top. On this page, enter the credentials. Once logged in, simply click on download button on the top right. This will take you to the page that displays about databases, tools, and all our software available for download. Now let's click on EDB Advanced Server to access package repository. Here you will see all the supported version of EDB Advanced Server with support and date. Also, you will notice couple of tabs. Some will say download and other are access repo. If you click on download, it means that the package is available for download right away. Simply click on download and it will start the download. And in case of access repo, the packages are resides in EDB repository. We need to access the repository to download the same. As we are using CentOS 7 for our demo, let's click on button access repo. Now to download the package from the repository, you need repository credentials which are different from your website credentials. To get the repository credentials, right click on view my account and open it in new tab. On this page, you will see your repository username and password. Currently, the password is hidden. To view the password, click on I button. Save this information for future use. Now coming back to previous page. Here you will see three boxes with different URLs to download packages from repository based on your OS environment. Based on our demo environment, I'll click on yum.enterprisegb.com. Now we are on EDB software repository page. On the left, you will see a drop-down menu. Choose your OS platform from the menu. I choose CentOS 7 based on our environment. Once you choose the platform, it will show all the tools available to download from EDB repository. You can choose your desired tool and version based on your requirement. For this demo, I will click on EDB Advanced Server 13, which is the latest version of EPAS and EFM 4.2. As you can see on the right, the system has generated the script to install and configure the tools. Either we can copy the entire script or copy individual command. Let's perform it with individual command. First command is to install EDB repository configuration. We need to run this command on all three servers. Copy this command and execute it on all three servers. After the successful execution of the above command, we need to run the second command. Second command is to modify the edb.repo file with repository credentials. This file is created by previous command. Again, run this command on all three servers. Copy this command and paste it on one server and change the credentials first. Copy the credentials from previously opened My Account view. Copy the username, copy password, execute. Copy this command and execute it on all other servers. Now next command is to install EPEL repository. EPEL stands for Extra Packages for Enterprise Linux. Again, you need to copy this command and run it on all three servers. The EPEL repository is basically to resolve the package dependency. Now it's time to install the selected packages. For this demo, we are configuring one primary, one standby, and one witness node. So EDB advanced server is not required on witness node. However, EFM is required to be installed on all three servers. Additionally, we will install Java as a prerequisite for EFM. Copy this command, paste it on primary server, add Java package name. Same on standby server. And on witness node, we will remove EDB advanced server and add Java. It may take some time to install all the packages. Once we are done with the installation of desired software, it's time to initialize the database on primary server. Run this command only on primary server to initialize the database. Copy this command and execute it on primary server. And start the database service with systemctl command. So now our database is up and running. To check the status, run systemctl command. It is showing it as active. Also, we can log in to a database, go to the binary location and run psql command with -d option to specify the database name. As you can see, now we are able to log in. Let's create a dummy database. It's successfully created. After the successful verification, now it's time to configure streaming replication. Fellow Manager requires that the Postgres streaming replication be configured between the primary node and the standby node. Fellow Manager does not support other type of replication. To start with the streaming replication configuration process, let's create replication user with replication privilege. Create user, rep user with replication privilege and password. Exit from the terminal. Now edit pghpa conf file which resides in your data directory. Data directory location for our environment is where lab edb as13 data pgh and file name is pghpa.conf. Scroll down. At the bottom, you will see an entry for replication connection. This is basically to allow replication connection from other servers. Press YY to make a copy of this line and press P to paste. Edit this line with connection information. Press I to edit the file. Enter the username which we have created for the replication. Edit the IP address. Enter the IP address of standby. Change the authentication method to MD5. Save the file. Exit from Enterprise DB user. Run systemctl command to reload. Now we are done with the configuration of primary server. Next step is to configure standby server. Switch to standby server. On standby server, it is important to verify that the database is not running. Verify using systemctl command. As per the output, it is not running. Also verify the data directory. It should also be empty. So it's in where live edb as data. Run ls command. It's empty. In our case, it is empty because we haven't initialized the database on standby server. However, if your data directory is not empty, please make sure to clean it. To take backup, we use pg base backup command. Now switch to Enterprise DB user. To take backup, we use pg underscore base backup command. pg underscore base backup takes a backup of running Postgres server. To view the available options with pg underscore base backup command, run pg underscore base backup with hyphen help. The output will show all the available options with pg underscore base backup command. Now let's run pg underscore base backup command with hyphen h to mention the IP of primary server, hyphen capital U to mention the replication user, hyphen P for primary server port, hyphen D to specify data directory location where we receive backup on standby server. In our case, it's varlib edb as13 data, hyphen R for replication configuration, hyphen capital P for progress. This command will connect to primary server and copy all the data to standby server. Press enter. It will ask for the password. It's done. As our database size is small, it didn't take too much time to complete. Now let's verify the data directory on standby server. EDB has13 data. Run ls-l. It has copied all the files and directories. Additionally, the standby.signal file has been created to signal the server to run in hot standby mode. It also edited postgresql.auto.conf to add connection information. To verify, run cat postgresql.auto.conf. In the output, you will see that it has added this parameter along with the connection information. Now we are done with the configuration and we can proceed to start the standby. Now switch to root user and run systemctl command to start the standby server. Check the status. It's running. Now log into enterprise user again. Log into PSQL prompt. Run select pg is in recovery. The output T means that system is in recovery mode. Now to verify and monitor streaming replication from primary server, log into PSQL terminal from primary server. First clear the screen. Switch to enterprise DB user. Run PSQL-D EDB. Run select star from pg stat replication. The existence of a row in the output means that the streaming replication is running. Now let's test. Create a dummy database, new, and verify from the standby server. Run /l plus. From the output, you can see that the newly created database has been replicated. It means that the replication is working properly. As you can see, we have configured streaming replication successfully. Now let's start the EFM configuration. To start with, let's create non-super user and database for EFM on primary server. Switch to primary server, clear screen, create user, EFM, password, test. Create database, FMDB, honor, EFM. Connect to FMDB database, run grant, execute on function pg underscore current underscore wall underscore lsn to EFM. Up arrow and edit it again with the name of other function, pg underscore last underscore wall underscore replay lsn. Again, change the name of the function, wall underscore replay underscore resume. Again, replay, pause. Also, pg underscore reload underscore conf. Run grant pg read all stats to EFM. Grant pg read all settings to EFM. Now the EFM user has all the grant privileges on required functions. So now we need to modify underscore HPA file on the primary and standby server to add entries that allow communication between nodes in the EFM cluster. Also add the entry for virtual IP in pg underscore HPA file so that our application will also be able to connect over virtual IP. Let's first exit from here. Open pghba conf file. Copy this line, paste. Enter the IP of all the servers. Change the authentication method to MD5. Change the user EFM and database FMDB. Create the multiple copy of this line and change the IP. In our case, 70 is our virtual IP, 73 is witness node, and 72 is our standby. Come to replication entry. Make a copy of replication entry for primary server as well. This is required in case of switchover where primary will become standby and start pointing to newly promoted primary server. Copy this line, paste, just change the IP. 71. Before saving this file, open this file on standby server as well. Exit from the terminal. Open from where lib edb as13 data pg hpa. Scroll down. Copy the entries from the primary server. Paste it. Copy this line and change the IP. Save the file. Login again. Run select pg reload conf. Now switch to primary server. Save the file. Log into PSQL terminal and run select pg reload conf. To reload the configuration, exit from terminal and switch to root user. First configure EFM on primary server and then copy property file and node file to other servers. By default, the configuration files are resides in etc edb efm directory ll. This directory will contain two sample files, efm.properties.in and efm.nodes.in. Create the copy of both the files without .in. cp efm nodes efm nodes cp efm properties efm properties. Change the ownership of both the file to efm user. chon efm efm properties efm nodes. Run ls-l to check. As you can see, the ownership has been changed to EFM. Now, before start editing the property files, create encrypted password for EFM user. So run usr edb efm bin efm and encrypt EFM. The last EFM is the cluster name. Password, confirm password. Copy this encrypted password. Now open efm.properties file. Clear screen. Enter. Enter DB username. It's EFM. Encrypted password. Port. Database name. FMDB. Scroll down. Enter the owner of the data directory. In our case, it's Enterprise GB. Scroll down. Name of the database service which used to restart the database. So edb -as 13. Scroll down. Enter the binary location for pg underscore ctl call. So it's usr edb as13 bin. Here we need to enter data directory location. In our case, it's where lib edb as13 data. Scroll down. User email. Here you need to mention the email address on which you want to receive email notification. As we don't have SMTP server configured, so I'm using the local address root @local host dot local domain. So now next we need to change bind address. So here we need to mention the local address of the server and the port to use for EFM. So IP is 192.168.156.71 and default port is 7800. And next parameter is witness. So as the server is not a witness server, so we need to mention false over here. Next, we need to change the value of auto allow host to true. Search auto dot allow and set it to true. And change this table.node file to true to make this file static so that EFM server will not be able to rewrite whenever new node join or leave the cluster. Now make the entry for virtual IP, escape and Search virtual, enter your virtual IP, interface. In my case, it's INS33. Enter the prefix based on your network. Save the file. So now we need to update the efm.nodes file. efm.node files is read at startup to tell an agent how to find the rest of the cluster. So open this file, efm nodes. Make an entry for all the IP in a cluster with port. IP of local machine 71 with port 7800. Here two copies and change the IP. Save the file. Now start the EFM cluster using systemctl command. It may take some time. Now check the status using EFM command. EFM when EFM cluster status EFM. As you can see, the primary is up, and also it is showing the IP addresses of other nodes in allowed node host list. Now copy efm.properties and efm.node file to other two servers. So scp efm properties efm nodes IP 72 etc edb efm. Enter password. Also copy these files to witness node. Now come to standby server. Exit from the shell. Go to efm.properties file location. Run ls-l command to check the ownership. Change the ownership. Chon efm efm.properties efm.node. The efm.properties file can be same on every server except two parameters. First one is bind.address, the property to use the local address, and the another one is witness. If the node is witness, then set it to true, else false. Open the properties file, change the bind address, and we are not required to change the is witness parameter on standby server. So save the file and start the EFM cluster. Systemctl start edb -efm -4.2. It may take some time to start. Now check the cluster status. Run this cluster status command again. So as you can see, the standby is added to the cluster, At the bottom of the output, it is showing that standby database is in sync with primary, so it is safe to promote. Now let's configure witness node and add it to the cluster. Go to EFM file default location, which is cd/etc edb EFM, press enter and list all the files. Change the ownership of the file to EFM. Open the properties file and change the bind address and change is witness to true. Now save the file and start the service. It may take some time to start. Now let's check the status again. Run that command again. From the output, you can see that witness is added to the cluster. As our cluster status output shows that the primary and standby are in sync and it is safe to promote. So let's try it with switchover command. To switch over, go to binary location and run EFM command, which is user edb EFM bin EFM promote EFM and switch over. Run this command. As you can see, the command is executed successfully. Now let's check the status. Run this command. As you can see, the switchover command has promoted the standby and reconfigured the primary database as a new standby in the cluster. To switch back, run the command again. Now check the status again. Run cluster status command. So as you can see from the output, we are back to the original state. So now I am done with the demo. It's time for Q&A.
Thank you very much, Amandip. That was really wonderful. I think we had a few questions asked while you were presenting, and uh, I think between yourself and Manish, we managed to answer those questions. I believe so. But I still have a couple more questions. One of them is, can you tell us, does EFM support synchronous replication?
Yes, EFM can support synchronous replication, but it is recommended to have more than one standby, so that if your standby one stucks, then second standby will be available to send the acknowledgement to the primary server. But yeah, it is supported.
Thanks, Mandip. Before I go to the next question, can I ask the attendees, please do share with us any topics that you would like EDB to run for this office hour webinar series in future. We will take all your suggestions into consideration and organize webinars on topics that are of interest to you. So do please keep those suggestions coming. Of course, you still have an opportunity to tell us when I send this recording and slide deck out to you after the webinar. But if you have it now, do share with us. So, okay, moving on to the next question, Amandip. There's another question on: do we have any GUI GUI tool to monitor EFM?
Yes, we can monitor EFM from PEM, and also we can manage from there. We can perform switchover, failover from there. So yes, we can use PEM to monitor the EFM servers.
Thanks, Amandip. There's a question in the Q&A box. I think this one is from Bernard, but I believe Manish is providing him the answer. You can read it out if you want. He's asking, is it mandatory to install EFM services as root user?
Yes, on Linux, if you want to perform install any tool, we need root access. But once we install, we can manage EFM using non-sudo user as well. We have a document on that. You can go through that. But installation needs root access.
Thanks, Amandip. Also, True Citra has asked another question. It's previously we have create recovery.conf file for replication in 13. It doesn't need, I'm not quite sure what is asked here. I think
I
basically, yeah.
Actually, in before version 12, Postgres version 12, we need to create a recovery.conf file to mention all the parameters related to replications. But those parameters from version 12 are integrated in the configuration file, and one empty file is created with standby name. So that file is created, but recovery.conf file is not required anymore. And once the all the parameter which are included in the config postgres.conf file, the benefit is that now you can use reload if you change any parameter. You don't need to restart every time if you change any parameter in recovery.conf file. So it is a benefit, and now it is not required.
Sorry, I was on mute without knowing. Amandip, are you able to read to see the question? What is the purpose of FMDB, and what is it used for?
We have created a sample database along with the non-super user to perform this EFM, so that we don't want to provide access to uh, uh, our database, and for that we have created this sample database. You can create this with any name.
Okay, related to the FMDB, there's another question. What is the use of EFMDB? Are we replicating only one database instead of complete instance?
No, we are replicating the complete instance. This is just to run, as we have created one user, that user need some uh, privileges to run few functions to manage and monitor the cluster. For that, we have provide access to one database, a sample database, so that it will not get access to our other databases, which are our production databases. So for that, we have created a sample database, FMDB, and that can be of any name, but it will replicate all the database. It will not going to replicate only FMDB. It is just for the monitoring.
Thank you, Amandip. One more question. Um, this is in case failover to slave due to server failure and after server up, is it automatically become slave and catch up the gap? If no, how we can recover primary if the database is very large, for example, 10 gigabyte.
uh, it will not going, in case of failover, it will not going to reset up. Either we can use pg rewind, or we need to set up it using by taking backup and then restore and make that server as a standby to the newly promoted primary. And then once it become a standby to the newly promoted primary, then we can use switch over to come back to original state.
Thank you, Mandip. There's still another question on FMDB. This person, Praveen, asked, do we really need FMDB?
No, it's optional. You can use any db.
Thank you, Mandip. So maybe I think we have time for one last question. Um, do we need any separate license to use EFM?
No, it's included in our enterprise licensing. So we don't need any separate license for the for using this EFM tool.
Thank you. Okay, I think since we have about 5 minutes, I will just quickly read two more questions that just came in. Um, this is from Bernard. He says related the VIP in which physical Ethernet device we had to map. Is it the same with the physical Ethernet that database listening to?
Yes, you need to define the same that interface name, or if you have any other interface, you can use that as well. And on that, it will automatically configure virtual IP to use for your application.
Thank you, Amandip. One last question. How does EFM differs from pacemaker OS level cluster?
In OS level clustering, your primary, you have at any point of time, you have only one primary available to access your data and read write and perform read write operation. But with EFM, you have your standby also available. If you want to perform reporting tasks from there, you can do that. You can offload your server load and use that standby to run your reporting and other queries like select queries. So it will be helpful. But in case of OS level, you will not get access to your standby, because that standby will be in a passive mode. It will only be become active in case of failover. So this is the basic difference.
Thank you very, very much, Amandip. I think we really is at the top of the hour, and I would really want to thank everyone for taking time to attend. Um, I will be sending this recording out to all of you, including the slide deck. Please do let us know. There will be an opportunity for you to indicate what you like to see from EDB for this office hour webinar series in future. Do let us know so that we can organize more relevant webinars that will truly meet your needs and answer your questions. So without further ado, I just want to thank everyone again and close this webinar. Thank you all and really appreciate your support and attendance. Thank you. Have a good day ahead. Bye.